Alright guys, welcome to this page of the notes, and again what we're doing is we're continuing with our first objective, which is terms in geometry. Learning how to both speak and write or read the language of geometry. And let me make this quick note about these videos as you kind of work your way through them. What I would love to happen for you, the way for you to use these videos, is not that you would watch every second of the video. Please feel free to. I make lots of really good jokes, plenty of useful information. Awesome if you watch every second of it, but that's really not the purpose. What I hope is you would get to the point where what you're doing is you're working ahead. Once you feel comfortable with a particular topic or concept, that you would go ahead and try the problem on your own, and then simply come back to the video to check and see if you got what I got. Please keep in mind that if you use the videos that way, you're working ahead and then just simply checking your answers with what I got, just laying my cards on the table here. Sometimes in geometry, it's possible for your answer to be different than mine, but you still to be correct. It's gonna happen. These next two are a really good example of that. Or even the drawings we did in the previous video, on the previous page of the notes, there were a couple of places where I didn't specify exactly where you had to put a point, and you could have really put it anywhere and still have been correct, okay? So just please watch out for that as we go through geometry. Sometimes there'll be more than one right answer. Not always, but sometimes, and you just want to be aware of that. But please, I would love, if you find the best way to use these videos is by working ahead and then just simply coming back and checking your answers. If you got it right, fantastic, move on. No need to waste your time watching the video. If you got it right, move on, man. Whew. If you got it right, move on, keep going. If you got it wrong, watch and see what I did. Maybe we can figure out where you went wrong, some sort of misconception or something like that that we could fix. So that would be a great way to use these videos. So doing it that way, then here's what we've got. I want you to write a description. On the previous page of the notes, I said that you need to be able to do two things. You'll both need to be able to read a description and draw a picture, which is what we did on the previous page. The second thing you would need to be able to do is, given a picture, write a description of that picture. And that's what we're going to practice right here. So what I've done is I have given you this picture, and I want you, diagram, picture, figure, whatever, I want you to write a description of it. So here we go. Here's what we're going to do. Well, here's what we've got. First thing I'm going to do is I'm going to let you know that I have a plane M. So, actually, here's, let's describe what's going on. I have plane M, all right? I have a line K that is in, right, in the plane, okay? And then I have this line J, all right, that passes through point P. Now, for the sake of this example, and actually I probably shouldn't do this because it isn't drawn correctly, but just to sort of make things interesting, I'm going to do this. This line right here, J, in fact, let me do it in a color that is different than the rest of it so that you can see it. I want right here, starting at point P and extending down, I want that bottom part of the line to be dotted, right? What does that mean? Here's what that means. Imagine that you have a plane and the line J is coming down and extending down through the plane. So out the top and through the top and out the bottom, all right? Line J. So the dotted line here would be the portion of the line, right? If this guy were kind of tilted toward you, it would be the portion of the line that you couldn't see that's hidden by the plane until it extends far enough down that you could again see that line, right? So I've got that line kind of going through the plane. So the dotted line just simply represents the portion of line J that's out of view while it's hidden by the plane, and then it extends down the rest of the way, okay? So let's do it this way. Because it wasn't a dotted line, that would indicate to you that line J is also in the plane. So instead of extending down through the plane, line J would simply lie in the plane, right? It'd be a line that is in that plane. They're on the same surface, okay? That's if there is no dotted line, which is the way it was drawn. But just to help make things a little bit more interesting, let's do this. Instead of having that line be in the plane, let's just flip it up so that it's extending through the plane. And we can do that by those dotted lines. Okay, great. So here we go. I have line K that is in plane M, and I have line J that is coming down through and intersecting plane M. So here we go. This is what I would write. And again, there's more than one way to write this, but I think maybe this would be the simplest way. We would have the line, again, I'm going to do my best I can, lowercase italicized letter, so the line K lies in plane, and again, capital italicized line, or in plane M, okay? And then I have line italicized lowercase, so J, that's a terrible italicized, really tricky. I apologize when I'm writing these myself, I'm sorry, but that is line J, so that's italicized J. Line J, and we'll put intersects, right? Because it comes down and intersects that plane, but then extends all the way through. So line J intersects plane M at point, right? Where does line J intersect at? At point P, capital, unitalicized point P. And that is actually a beautiful description of this particular figure. Is it the only way? It is not. It is not the only way, but it is a good way. And if you try it some other way yourself, and you're taking this class with me, please feel free to check your description with me and see, because it is possible to describe this thing wrong. And so if you're not sure if you wrote it different than mine and you're not sure if yours is right, just if you've taken this class with me, let me know and I'll be happy to work on it with you as well. All right, here we go. We've got another one. I apologize. This one may be a little bit trickier to see. Hopefully you can see what's going on here. I have a plane that is vertical. I have a plane that is horizontal. Again, the dotted lines simply represent the portion of the plane that is hidden from view by the other plane. So dotted line there for the portion of plane Q that's hidden by P, and then dotted line there for the portion of plane P that's hidden out of view by plane Q. Again, really important, we mentioned it before, when two planes intersect each other, they'll intersect at a line, and that's exactly what I've got right there, that line right there intersecting the intersection of those two planes. All right, so we want to write a description of this, and I think this is going to be a good way to do it. Again, not the only way, but a good way to do it. We're going to put that plane. Doesn't matter which one we do first, we'll do plane Q, intersects plane P at the line. Oh, look at this. Okay, notice that line, all they've given you is 2 points, A and B, which means you cannot use a lowercase italicized letter, which is another way for naming a line. But they didn't give you a lowercase italicized letter. They only gave you 2 points, and that's what you're going to have to use. So the line, and again, order doesn't matter. You could call it line AB, you could call it line BA. That's fine. That's totally up to you. I'll call it line AB because I prefer to put them in alphabetical order, but that's me. I'm kind of weird that way. And then, of course, I let you know it's a line by putting the bar with the double arrow over top. And guys, that's a beautiful description. It's not the only way to describe it, but this is a really good way of describing that, that diagram, that figure. Plane Q intersects plane P at the line AB, that line that it represents the intersection of those two planes. All right, guys, head on over to the next page of the notes, and let's take a look at a couple more things here for this. Here's what I've got for you. This is just going to kind of be some ways to sort of check your understanding of what we've done so far. And again, when it comes to these videos, please pause, stop, rewind, watch as many times as you need to really sort of solidify these concepts. Remember, the idea here is mastery. We want you to master this material, and that does not mean just memorizing it real quick so you can take a quiz or a test, right? That means going over it, doing practice problems, doing it and doing it and doing it until you've really sort of put that in long-term memory. It's something that you'll remember how to do. We're just going to keep practicing some of these things, and again, please use this video in a way that helps you best understand everything that we're covering here. I've given you this figure right up here. All of the questions we've got below will hopefully relate to that figure, and we're going to ask some questions here, hopefully, that will really sort of help you begin to process some of the information we've already gone over here in the previous pages of the notes. So let's start here. Lines are indefinite, consisting of an infinite number of points continuing in either direction. So here's what I've got. I've got this enormous line here, line AC, right? I'm using those 2 points, AC. The question is, can you come up with other ways to name this line? Well, yeah, sure we can. We could call it line AC. You could have called it if you wanted to. Please remember, when it comes to a line, the order doesn't matter. I could have called it, I'll write my answers up over here. I could have called it line CA. Guys, that means the exact same thing as AC. When it comes to a line, the order of the points doesn't matter. But those aren't the only points I gave you on the line. I gave you A and C, but you also have the point B and the point D. You could have called it line BC. You could have called it line BD, or any other plethora of combinations of those 4 points. All perfectly legitimate ways of naming this line. All of them would work, okay? So there's many, that's not an exhaustive list. There's many other ways. Also, remember, it wasn't given here, but if you're sort of describing your own figure or object or picture, you certainly could have, if you wanted to, instead of using points, hey, you know what? I'm going to go ahead and give that line a name with a lowercase italicized letter, and I could have called this the line N, right? Line N. Lowercase italicized letter. So lots of different ways to name a line, and hopefully you are okay with that. Let's move on. Try another one here. Here's what we've got. The segment. Okay, so again, remember this diagram up here, here's what we've got. Segment, a line segment is a portion of a line. We have a line, but we're just going to take a little piece of it, a little piece of a line, portion of a line that has 2 endpoints, right? That 2 endpoints that are part of the line. All right, so here's what we've got. We have the segment AC, which I have highlighted in red for you, right? The line segment AC. The question I have for you is, the line segment AC, is it the same as the line segment CA? And I think we've actually already talked about this a little bit. When it comes to line segments, it doesn't matter which direction you look at it. The answer is yes. The line segment AC is the same as the line segment CA. They're the same. So my answer to this one would be yes. Yes, they are the same. Now, what do segments AC and BC have in common? How are they different? All right, and please take a second. Try to come up with an answer on your own. Think about it. Look at it, right? Remember, what we're trying to do here is all the stuff we've talked about in the previous pages, by asking you sort of these more in-depth questions, by making you think about those things that we've gone over, hopefully what it's doing is giving you a chance to kind of process that information and figure out ways to use what you've just learned and hopefully really sort of solidify those ideas in your own mind about the way that these work. So please, please, please try these on your own and then check with me and see what you get. So if you've already done that and you're coming back, here's what we've got. What do segments AC and BC have in common? Well, let's find them. There's the line segment AC. It's highlighted in red. The segment BC, here I'll just highlight that in green for you, that guy right there, BC. All right, I'm asking you, what do the line segments AC and BC have in common? And then I ask you, how are they different? Well, here you go. Line segment AC and BC are line segments of the same line. So I would simply put, they are both segments of the same line. Right? If this were line N, line segment AC is a segment of line N. And line segment BC is also a segment of line N. That's what they have in common. How are they different? Well, it's not that difficult. Take a look at it and see. You can clearly see that line segment AC and BC are different lengths. So your answer to that part would simply be they are different lengths. They don't have the same measure. If you were to use a ruler to measure AC, it would not be equal to the measure you get for BC, right? So what do they have in common? Both line segments of the same line. How are they different? They don't have the same length. They would have different measures, all right? So guys, again, just this idea, hopefully what we're doing is making you think a little bit more about what we've learned and kind of apply it here and really sort of solidify that stuff for you. Measuring a segment, the measure of line segment is the distance from one endpoint of the segment to the other endpoint. Again, I probably didn't have to say that, but just in case, you could certainly use a ruler. I told you many of the constructions we'll do, you can do with just a ruler and a compass. And a ruler would certainly help you measure the length of that line segment. Okay, finally, array. Array is a portion of the line that starts at a point, an end point, and continues forever in one direction. We could have the ray AC. So let me go back up here. Here's our diagram. Let me do a different color than the ones I've already used. How about blue? All right, so I have the ray AC, so that would be a ray starting at A and extending through point C and heading off in that direction. Just kind of ignore that part right there. Right there's the ray AC. All right, so my question for you then is this one right down here. Is ray AC the same as ray CA? Well, actually, we've already talked about this on a previous page. If I have A, C, there's ray AC, and I have A, C, there's ray CA. Are those the same? And like we said before, the answer is no. No, they're not the same. Yes, they're both using the same points to describe the line, but the rays are heading in opposite directions. This one's heading off to your guys' right, this one's heading off to the left. And so your answer to this would be no. They are extending, extending in opposite directions. So again, the idea is this. The point we really want to drive home with array is that the order matters. You'll always start with the point that represents the end point extending through whatever other point that ray extends through. Which means then that if you were to switch the order of the points, you no longer have the same ray. Now you have a ray starting at point C and extending in the opposite direction, and those are not going to be the same ray. They're headed in different directions, okay? So just really hopefully that makes a lot of sense. Guys, this is awesome. I'm having a great time. Head on over to the next page of notes. We'll keep going with this idea of sort of an introduction to geometry, and I'll meet you guys over there.